Hi guys, welcome back to In Case of Econ Struggles. Welcome to another causal inference struggle. Today we're talking about partial identification or set identification. The idea behind set identification is that maybe there's some feature of your data where you get a point estimate, but you're not exactly sure if that point estimate is plausible or not. You're not sure if that point estimate makes sense or not. So what do? You think about the range of possible values that your parameter could take, and you use that set of plausible values to draw qualitative conclusions about your results. So I think this is most helpful with an example. Timestamps are below if you would like to jump around, but let's go ahead and get right into that basic example. So here is this basic example. Let's say that there's a new pill or new treatment on the market, and it's only for terminally ill patients, so it's only for patients who are really, really sick. And you're only going to give this pill to those terminally ill patients because it wouldn't be helpful if you are not terminally ill. So the only treated population is going to be people who have this terminal illness. You give them this pill and you see that 60% of those patients survive, and you're trying to think about the plausible range of values that your treatment effect of this pill could take. You've only given this pill to terminally ill patients. You have this 60% survival number. How can you use that to think about a range of plausible values for the efficacy of this treatment? Well, what we're going to do when we're finding the range of possible values for this effect is we're going to try and think about the worst case scenario or be super pessimistic. And we're also going to think about the most optimistic scenario, and we're going to say those are the endpoints of this set of the range of possible values that this could take. So what is the optimistic scenario here? Well, the optimistic scenario is that all 60% of these patients would have died but for the treatment, which means that your average treatment effect of taking this pill is plus 60% in terms of your chance to live. Well, what is the pessimistic scenario? Well, the pessimistic scenario is that 40% of these people did not survive. We say maybe the pill is actually harmful, and 40%, those remaining 40% would have survived except for or but for this treatment. So the average treatment effect of this medicine is minus 40%. You can see that without further information, we're not sure if this pill is actually helpful or not because the range of plausible values range from minus 40 to 60, and we're not sure if this pill is actually helpful or not for patients. Let's do a more complicated example using my favorite sort of example where we're talking about cats. So let's say that you have a lottery to get into this cat information session. That's going to be our treatment, and your outcome is whether or not you adopt a cat. So we have people who went to the info session. We have people who did not go to the info session. 70% of people who went to the info session got a cat, while 25% did not. 5% of people went to the info session, and then they never answered the follow-up survey about whether or not they got a cat. So they were just lost. We'd have no idea where they are or whether or not they got a cat. For the people who did not go to the cat info session, 50% of people got a cat, 45% of people did not get a cat, and again, 5% of people, we don't know what happened to them. We don't know whether or not they got a cat or not. Well, just looking at the numbers, we can see that our point estimate would be, well, 70% of people got a cat in the treatment group and 50% of people got a cat in the control group. So maybe this cat info session increased whether or not you got a cat by 20 percentage points. 20 percentage points because it's going from 50% to 70%. It's not a percentage change, that's percentage points. Percent is something different. So that's a 20 percentage point increase based on this treatment. But we have these 5% of people who never followed up with the survey. So using those 5% in each group, what is the plausible range of average treatment effects from this cat info session? What is the range from the most pessimistic scenario to the most optimistic scenario? Well, we know when we calculated this average treatment effect or this point estimate, not based on using this 5%, we took the 70% of people who were in the treatment group and got a cat. We subtracted the 50% of the people who got a cat in the control group. We got this 20 percentage point increase as our average treatment effect. How can we make this number as low as possible? Well, we make this 70% as low as possible, and we make this 50% as high as possible. That is going to bring down our average treatment effect. How can we make this number as large as possible, this average treatment effect as large as possible? We make this 70% as big as possible and this 50% as small as possible, and that'll make this number as big as possible. Notice that in each of these groups, we have this 5%, so we can assume different things about the 5% in each group to make this number bigger or smaller, this number bigger or smaller, to make this number as big or small as we want. So in the pessimistic number, we're going to assume that the 5% of people who did not answer our survey, they did not get a cat. And the 5% of people in the control group who didn't answer, we're going to assume they did get a cat, which is going to make this number as small as possible and make this 15 percentage points. On the other side, if we want to make this average treatment effect as large as possible, let's assume that the 5% of people in the treated group who didn't answer our survey, let's assume they did get a cat. Further, let's assume that the 5% of people who didn't answer our survey who were in the control group, they didn't get a cat. we're going to make this number as big as possible, and that's going to give us an average treatment effect of 25 percentage points. So you can see that our range went from 15 percentage points to 25 percentage points, which tells us that even if we're not exactly sure what this number is supposed to be, whether it's 15 percentage points, 20 percentage points, or 25 percentage points, we can say for sure that the range of plausible values in our data tells us that going to this cat info session definitely increased the likelihood that you adopt a cat. And that's really what we're looking for, and that'll help us confirm the results and be more confident in this qualitative result that the cat info session influenced and positively affected whether or not you get a cat. So hopefully this gives you a better understanding of set identification or partial identification. If this was helpful, make sure to like and subscribe, and we will see you next time for another case of econ struggles.